Good morning, boys and girls. I'm Mr. Gonzalez.
And I'm Mr. Hodson.
And we're here to
Tax you up.
That's right. It's another edition, another year of our tax problems.
Yes, sir.
So let's get to it, Mr. Hodson. What's our first problem?
First problem, the net of the cylinder is shown below, which is right here. Use the ruler on the math chart to measure the dimensions of the net to the nearest 1/4 inch, which is the closest to the total surface area of the cylinder.
Very good, Mr. Hodson. And I think it's important, students, as you get your problem, please understand what the problem's asking. And in this case, the problem's asking for the total surface area of the cylinder. Okay?
Please underline that.
Yeah, good. That's a good point to make, Mr. Hodson. Now let's look. So we're looking total surface area of the cylinder. In an attempt to understand the problem, what are some key words you see here?
Mr. Gonzalez, I do not know what net means. So I'm kind of confused there.
All right.
I believe I do not see a cylinder here, though. Where's the cylinder?
Good point. All right.
And what does dimensions mean?
Dimensions. Very good point, Mr. Hodson.
Okay.
I think we covered a lot of the key words here. Let's talk about that. All right. First off, it's talking about a cylinder. And let's take, I have right here a model of a cylinder. Okay. The students can imagine a cylinder is like a Coke can. Okay. So as we see here, it has a top and a bottom, and it has this big old side. Now,
What's the top and bottom called?
we call those the base of a cylinder, and you can see it has two bases.
Two bases.
Two bases. Okay, but look, this looks nothing like what we shown here. But that's where we get the word net. A net means that you take a three-dimensional shape and you would show it if it was on a flat surface. Okay?
I'll hold that.
There you go. So we're going to take a look at this cylinder as we were to take it apart. There's my top base. There's my bottom base. And here's the section we would have in the middle. And if you notice, that's what we have here. Very similar. Top base, bottom base, and we have the rectangular piece. Now look over here. Right here, what is this length?
That's the height.
That's the height. So where would you show that here?
Is that there?
No, it's not there, because look, where's it between here?
Oh,
it's between
the bases. So,
it's between the bases.
I just dropped my marker, sir. Sorry,
That's
sir.
fine. So the dimension between the bases.
I'm going to put a blue.
You're going to put blue. Fine.
Right here. That's the height.
That's the height.
Okay.
So just remember, the height is the length between the bases. Very good.
All right.
All right. Now it's talking about that, so now we understand what that shape looked like, and here's the net of it, and total surface area. Students, when you take the TAKS test, there's something that's so great. It's in the back of the TAKS test, and that's a formula chart, the math chart. And on here it has several different formulas, and when you flip it to the back, it also has conversion tables, and it also has rulers. Very good. Just like I am your ruler, this is a ruler. There you go. All right, so let's look at what formula we would use here. When you look at the formula chart, it says surface area, and it does have cylinder, and it has lateral and total. Which one are we going to use here, Mr. Hodson?
Well, I believe I see total surface area, so total.
Total, you're exactly right. But what's the difference between lateral and total surface area?
The lateral starts with L.
Well, besides that, when we take a look at your TAKS problems, lateral means the area that would not include the bases. Okay?
Okay. The sides. Lateral means sides.
Lateral means sides. Very good, Mr. Hodson. So in our case, we're going to use total surface area. And let's point out, students, when you take your TAKS test and you're talking about surface area, please assume it to be total surface area unless it is specified.
If it says lateral, use lateral.
That's right. Otherwise, you're always going to be looking for total.
Okay.
All right. So if you would give me the equation, the formula for surface area.
Cylinder total. S equals 2 pi RH plus 2 pi r squared.
Just like you are squared.
I am very squared.
That's right. So in this case, wait, I do see an H there.
Can you, mine's blue.
All right, and I'll make mine blue. But where is the R? Where does that represent?
R stands for radius. I believe.
Radius. All right.
And I'm going to make mine red.
You're going to make your radius
And
red.
I believe this is the radius from the center of the circle all the way to
Okay, and
the
I'll make it
edge.
red over here. And students, when you work your TAKS problems, please make sure that you highlight your variables and highlight on your problems the different colors to represent your variables. Okay, Mr. Hodson, let's go ahead and measure those.
Okay, I made another measurement here. And I'm going to measure right here. And let's do R.
R.
Okay. And I get 5. Is that correct?
You do get 5, but Mr. Hodson, you're making a common mistake. The students, if you notice over here, you are measuring in centimeters. And yes, that was another key. Circle what dimensions you're talking about, what your units are. In this case, our units are inches. So use the scale that says inches.
Okay, I'll use the scale. Here's one that says inches. And now I get, for the radius, from 0, it goes all the way to 2.
Okay,
so
so
R equals 2.
R equals 2. I would put that. All right?
All right. And the height.
The height.
From one base to the other base.
That's correct, the height.
I get 1.5.
1.5. Because you're measuring to the nearest 1/4 inch.
Yes, sir.
Okay, remember. All right, let's plug these numbers into our formula. So I come over here, 2 pi. For R, I will put 2. For height, I would put 1.5. It's always good to use parentheses when you're entering a value for a variable. 2 pi, and my R is 2, and I have that squared.
Okay.
Okay. Now, let's do the first part of this.
Sir, none of these answers have decimals.
That's right. So on your calculator, go to the mode feature, and your teacher will be pointing those things out to you. Go to the mode feature where you would set your place value so you have just to the ones.
The ones place. Okay. No decimals. Let's see. Do you want me to enter the whole thing?
No. Let's do one section at a time.
Okay.
Yeah.
Do you, another question. Do I use 3.14?
Use the symbol pi that's on your calculator.
Okay, I see.
Okay?
It's
Yes.
blue.
Yes.
It's blue. Okay, got it. Do I put the parentheses on the calculator?
I would put the parentheses. You may enter it just like it is.
I'm just asking. And I got 2 pi, 2 times 1.5. I get 19.
19. Very good, Mr. Hodson. Now, of course, we do have our next. We have addition. And make sure you always put a number that you're going to raise to a power absolutely always in parentheses.
And don't put the square inside the parentheses.
No, on the outside.
On the outside. 2 pi, I get 25.
25. Okay, 19 plus 25, and what's our final answer there?
44.
44.
Did I do something wrong? Because I don't see it here.
You don't see it here, but if you notice, it says what is the closest to this total surface area. So if we look at our answers here, the one that is closest is
43.
43. Very good.
C.
C would be your answer.
Do you see the answer?
I see it.
You see
Si, senor.
All right.
That's right.
There you go.
So there we go. So students, I hope you remember some of our key terms. The net, to make sure you always look for surface area.
surface.
Yes, look for total surface area. And I think you brought up a very good point, highlighting your different variables.
Here, and then highlight them on your paper the same colors.
That's right. So I hope this helps you out. We'll see you soon so we can be here again to
tax you up!